Welcome to A-Level Chemistry. Today we will go through the October-November 2021 paper 11, which is the first variant of the multiple choice paper for this session. And while we go through the paper, I'll show you some tricks that you can use during the exams to get a good score. So before we delve into the questions, as I always say, read the questions carefully, because when I used to practice for my exams, I used to read the questions in a hurry and I always left out some important detail and I ended up making lots of silly mistakes. So to avoid that, read each and every question carefully and it will become much easier to answer the questions and get a good score. So we start with question 1. The mass spectrum of a sample of neon is shown. The relative abundance of each peak is written in the brackets above. What is the relative atomic mass AR of the sample of neon? So to calculate the AR, there's a simple formula, which is we multiply the mass of each isotope with the abundance and divide by the total abundance. So 20 times 100 plus 21 times 0.3 plus 22 times 8 divided by 100 plus 0.3 plus 8. And that gives you 20.15, which is option A. Then question 2. A 2 gram sample of ammonium nitrate decomposes to give 0.9 grams of water and a single gas. What is the identity of the gas? So we write down an equation, a tentative equation, because we don't know the identity of the gas yet. So this is H2O plus question mark. So we can first calculate the number of moles that we have here. So the MR of NH4NO3 is equal to 14 into 2 plus 4 plus 16 into 3, and this is equal to 80 grams per mole. And then we calculate the number of moles of NH4NO3. So N of NH4NO3 is equal to 0.025, because 2 divided by 80 is 0.025, and N of H2O, because they've given us how many grams of water have formed, is equal to 0.9 over 18, which is 0.05 moles. So this shows us that ammonium nitrate to water is in a 1:2 ratio, and therefore we write a 2 over here. So now it becomes easy to find the question mark here. So 4 hydrogen atoms, 4 here. In total there are 3 oxygen atoms on the left and 2 on the right, which means that there is 1 oxygen in the question mark. So I'll write question mark equals to something and oxygen. And what we are left is 2 nitrogen atoms. So we want 1 oxygen atom and 2 nitrogen atoms, and the only option for that is N2O. So C is the answer. Question 3. Which of these elements has the highest 5th ionization energy? So let's go through all the options. Now for carbon, the electronic configuration is 1s2, 2s2, 2p2, and for nitrogen, the electronic configuration is 1s2, 2s2, 2p3. So the 5th ionization energy, as we go from carbon to nitrogen, so it means we are removing 5 electrons, and if we remove 5 from carbon, we are removing the last one from the 1s orbital, and if we remove 5 from nitrogen, we are removing it from the 2s orbital. And you'll ask why I'm not talking about phosphorus and silicon right now, but I'll explain why as we go on. So for carbon, I repeat, we are removing the 5th electron from the 1s orbital, and for nitrogen, we are removing the 5th electron from the 2s orbital. And as you know, the 1s orbital is much lower in energy and much closer to the nucleus than the 2s orbital. So it's more strongly attracted to the nucleus, and therefore it will take more energy to remove the electron, and hence carbon is a viable choice. Now, the reason why I didn't look at phosphorus and silicon right away was because phosphorus is below nitrogen in the periodic table and silicon is below carbon in the periodic table. And as you all know, the ionization energy decreases down the group. So therefore, there is no point of looking at these because we know that they are going to have a lower ionization energy than carbon and nitrogen. So these are the tricks you need to have in mind so that you can quickly answer these questions. So the answer is A for this one. The next question is, the ion X2 plus has the same electronic configuration as the atom krypton. So what is the electronic configuration of an atom of X? So remember, X2 plus has the same electronic configuration as krypton, not X. So be very careful about that. So let's look at the electronic configuration of krypton. We know that it will have krypton is in the noble gases, which means that its last electrons will be in the p orbitals, and therefore we keep that in mind. So if we look at this one, the first one, argon, which is a first 18 electrons, 4s2, 3d10, 4p6. This is the electronic configuration of krypton itself if you look at the periodic table. And we are told that the ion X2 plus has the same electronic configuration as krypton. So this is the electronic configuration of X2 plus, which means it cannot be the electronic configuration of X itself. So this is not the correct answer. Option B, the same thing as A, but we add 2 electrons. Now this is possible because if you remove the last 2 electrons, you'll get this electronic configuration, which is that of krypton and X2 plus. So B is a suitable answer. And if you look at the other options, they are not really possible because after 4s2 you fill 3d and not 4d. Remember, 3d always fills first. If you remember this rule, 3s, 3p, 3d, 4s, 4p, 4d. So 1s fills first, then 2s, then 2p, then 3s, then 3p, then 4s, and then 3d. So remember this rule, and therefore C and D cannot be the answers. So the answer is B. Question 5. Which type of interaction exists between water molecules and metal cations in aqueous solutions? So the answer should be C directly because remember, metal cations are ions, water molecules have dipoles and ion-dipole interactions. They cannot be dipole-dipole interactions because metal cations don't have a dipole. They cannot be ionic bonds because water molecules are not ions. And they cannot be hydrogen bonds because, again, those are between molecules, not between molecules and ions. Question number 6. Which substance shows the greatest deviation from the properties of an ideal gas under room conditions? So to deviate from an ideal gas, remember, what is an ideal gas? What are the properties of an ideal gas? So an ideal gas does not have any interaction between the particles. The particles themselves have negligible volume, and the particles they behave ideally in the sense they agree with the ideal gas equation, which is PV is equal to nRT. Now, the only gases that come close to ideal behavior are the noble gases. So neon, they've given a noble gas here, and they say which substance shows the greatest deviation from the properties. So neon definitely, but not because it is an ideal gas, so it will not deviate from the properties of an ideal gas. Then hydrogen and carbon dioxide, this is the structure of carbon dioxide, and because of the symmetry, it's nonpolar. And hydrogen, diatomic molecule, nonpolar. So this means because these are nonpolar, there will be very minimal interaction between the particles. So we can rule these out as well. And then ammonia, You know that ammonia gas, nitrogen and hydrogen have different electronegativities, which makes ammonia very polar, so the molecules will attract each other. In fact, they will attract each other very strongly through hydrogen bonds, and therefore ammonia will deviate from ideal behavior because of the attraction between the molecules. Then question 7. In order to determine enthalpy of neutralization of a strong acid and a strong alkali, 25.0 centimeter cube of 2 mole per dm cube sodium hydroxide is added to 25 centimeter cube of 2 mole per dm cube hydrochloric acid. The increase in temperature is 12 degrees Celsius. In the second experiment, the same method is used, but 50.0 centimeter cube of 2 mole per dm cube of sodium hydroxide is added to 50.0 centimeter cube of 2 mole per dm cube of hydrochloric acid. So in this one, we will use the formula Q is equal to minus mc delta T, and let's label this situation 1 and let's label this situation 2. So first let's talk about situation 1. Q is equal to minus mc delta T. M is the total volume, which is 50 centimeter cube, because 25 centimeter cube of sodium hydroxide and 25 centimeter cube of hydrochloric acid. So the total volume is 50 centimeter cube, and that's M. C is the specific heat capacity of water, but we will not use the value here because that's not important. So Q is equal to minus 50 into C, whatever it is, into delta T, which is 12 degrees Celsius. And this comes out to be minus 600 C, right? Now let's calculate the Q per mole of NaOH or HCl. So the number of moles of each of NaOH and HCl is equal to 25 divided by 1000. Remember, centimeter cube we have to convert to dm cube into 2, which is equal to 50 over 1000, and 50 over 1000, let's leave it at that. And therefore delta H, which is equal to Q over N, is equal to minus 600 C over 50 over 1000, and this is equal to minus 12,000 C per mole in units of energy. Now let's talk about situation 2 right here. Let's talk about situation 2. Q is in this case equal to minus 12,000 C, because what we have done, because we know that M is equal to the total volume, and C we have taken as it is, and what we have done is that Q is equal to minus 12,000 C into 50 over 1000 into 2, because 50 centimeter cube of sodium hydroxide and 50 centimeter cube of hydrochloric acid, and this will give us the value of Q, which is minus 1200 C, because remember we are doing delta H is equal to Q over N, so Q will be simply equal to delta H times N, and delta H we know is minus 12,000 C, because the enthalpy change will remain the same because it's the same acid and alkali, and the enthalpy of neutralization remains the same. Remember, enthalpy of neutralization remains the same, and we multiply the minus 12,000 C into 50 over 1000 into 2, because it will give us the value of the energy, because it's essentially delta H times N, and N is basically the volume times the concentration. And then we know that Q is equal to minus mc delta T, and delta T is therefore equal to minus Q over mc, which is equal to 1200 C over M is 50 plus 50, which is 100 centimeter cube. We have to convert it to we can actually leave it at centimeter cube, so it's equal to 100 over 100 into C, and we can cancel out the C's. 1200 over 100 is equal to 12, so that's B is the answer. Question 8. Which equation represents the enthalpy change of atomization of iodine? So the definition of enthalpy change of an element is, enthalpy change of atomization of an element is when when 1 mole of gaseous atoms are produced of the element in its standard state under standard conditions. So iodine in its standard state is a solid, and we want 1 mole of gaseous iodine atoms, and the only equation gives this is equation C. So iodine, molecular iodine in its standard state, I2, solid state, gives us 1 mole of gaseous iodine atoms. Question 9. Zinc atoms can be oxidized to Zn2 plus ions by dichromate ions in acid solution. Chromium is reduced to Cr3 plus ions in this reaction. Which equation is correct? So let's look at all of these. To make sure that the equation is correct, we need to ensure 2 things. The charges on both sides of the equation are balanced, and the number of moles on both sides of the equation are balanced. If these two conditions are satisfied, then the balanced equation is correct. So let's first look at moles for A part. 2 chromiums balanced, 1 zinc balanced, 14 hydrogens balanced, 7 oxygens balanced. So moles are balanced. So we'll put a tick in front of M. But now let's look at charge. So we have -2 plus 14, which is 12, plus 12 on the left side. And we have +6 plus 2, which is 8 on the right side. So the charges are not balanced, and therefore this cannot be the answer. Same for B. 2 chromiums, correct. 7 oxygens, correct. 1 zinc, 3 zincs, that's not possible. And 14 hydrogens. So moles are not balanced. Don't even bother looking at the charges, because the moles are not balanced in the first place. But let's look at the charges as well. -2 plus 14 is plus 12. And then this is on the left side, and on the right side we have +6, which is 12, plus 12. So the charges are balanced, but moles not balanced. So this is wrong. Then option C. 2 chromiums, 3 zincs, 14 hydrogens, 7 oxygens, moles balanced. Charges -2 plus 14 plus 12 on the left side, +6 plus 12 on the left side. So both balanced, which means C should be the correct answer. But we will have a look at D as well. Always need to ensure that what we've chosen is correct. 4 chromiums, 2 chromiums on the left. So that's moles not balanced. Sorry, so moles not balanced because we have 4 on the left, 2 on the right for chromiums. 14 oxygens, 7 oxygens, again very bad balancing. 3 zincs correct. 14 hydrogens correct. Charges -4 plus 14, which is plus 10 on the left, to +6, which is plus 12 on the right. So both charges and moles not balanced. So this cannot be correct either. So C is the correct answer. Question 10. The equation shows that hydrogen gas and iodine gas react to form an equilibrium mixture. And they've given us the equation along with the enthalpy change. It's exothermic. A mixture containing equal amounts of hydrogen and iodine is made at room at temperature T1, and the composition of the mixture is monitored. A graph of the results is shown. So the mole fraction of iodine decreases from 0.5 to 0.23. The experiment is repeated at lower temperature T2, and which new graph would be obtained? So before we look at the graphs, let's look at the principle they're testing. They're testing Le Chatelier's principle because they've said they have lowered the temperature, and we know that a decrease in temperature favors the exothermic side of the reaction, which is the forward reaction, which means we expect more iodine to be consumed, and therefore we can say that option A and option C both are wrong because the same amount of iodine is consumed, and option D is also wrong because less iodine is consumed, because we expect equilibrium to shift to the right, and therefore B is correct. And we can also see from this that the rate of reaction is decreasing because the slope of the graph is decreasing, and that is correct as well because a lowering of temperature decreases the rate of reaction. So we expect an amount of iodine at equilibrium to fall, and we also expect the rate of reaction to fall. Now let's move on. So question 11. The diagram shows the Boltzmann distribution of energies for a reactant gas. For a particular reaction, the activation energy is X. Which change to the diagram occurs if an effective catalyst is added at the same temperature? Again, before reading the options, recall the principle. We know that a catalyst a catalyst provides an alternate pathway for a reaction to happen with a lowered activation energy, which means that there is no change to the graph itself, only the activation energy x1 will get lowered. So let's look at what the options say. A, more particles will possess higher values of E. This is wrong because there will be no change to the curve. So the same amount of particles, so the particles will have the same energy distribution as before. The peak will move to the left, no. The peak will move to the right, no, because the peak is not moving at all, because again, the catalyst will not change the distribution of energies, it will only lower the activation energy. Option D, the value of the activation energy decreases. Bingo. This is the correct answer because that's what we figured out before reading the options. Question 12. Which element requires the least number of moles of oxygen for the complete combustion of 1 mole of its atoms? And they've given us some elements. So best is to write down all the equations. So aluminium Al plus O2 gives something Al2O3. Let's balance it. 2 aluminiums. We need to make sure we keep 1 mole because the question says 1 mole. Again, read the question. And therefore this should be half, to make sure there is 1 mole of aluminium on both sides, which means there are 3/2 moles of oxygens, and therefore this should be 3/4 over here to make sure there are 3/2 moles of oxygen on both sides. Then magnesium, Mg plus something O2 gives something MgO. 1 mole on both sides magnesium, we don't need to change, but we are using half a mole of oxygen on the left to make sure it complies with whatever is on the right. So phosphorus, P4 plus something O2 gives P4O10. And we have 1 mole of phosphorus, P4 on the left, we have P4 on the right. So that's done. And then we have 10 oxygens on the right. So we need 5 moles of oxygen gas, which is quite high. And so this cannot be the answer because we know that it says the least number of moles of oxygen, and we know that both aluminium and magnesium are lower. So right now magnesium is winning this race of least number of moles of oxygen. Let's look at sodium. Na plus something O2 gives something Na2O. 1 mole of sodium, so we put half here. And then we have half oxygen on the right, which means we need 1/4 over here because 1/4 times twice is half. So sodium wins because it uses the least amount of oxygen. Question 13. An element Y reacts according to the following sequence. It burns in oxygen gas, gives a white solid. Stop right here. Look at the options. What could element Y be? White solid, sodium oxide, yes. Magnesium oxide, yes. Aluminium oxide, yes. P4O10, phosphorus oxide, yes. So till now, all 4 are in the race for this answer. Then from the white solid, we add HCl and it dissolves to give a solution. So it doesn't dissolve, it reacts or something. So again, sodium oxide is a base. It will react with HCl to give a solution, NaCl. MgO will react with HCl to give MgCl2, another solution. Al2O3 is amphoteric. It can behave as an acid and a base. So in the presence of an acid, it will behave as a base and it will also form something in a solution. And then P4O10 is acidic and it will probably dissolve in the HCl. So again, we can still consider all 4 to be in the race. Then we add sodium hydroxide to the white precipitate, and this makes things interesting because we get a white precipitate. So sodium hydroxide we add to the solution, and we get a white precipitate. So NaCl, till now we have NaCl, Mg, MgCl2, AlCl3 probably, and PCl5, I guess. Yeah. So white precipitate, I think we can now move phosphorus out of the picture, because I don't think sodium hydroxide will react with PCl5, and we have not been taught much about it. So let's not focus on it too much. Then we have three of these things to consider: NaCl, MgCl2, and AlCl3. And if you look at your qualitative analysis booklet, you'll know that when we add NaOH to NaCl, it will probably have no effect because the sodium ions are still there. So it's a competition between magnesium and aluminium. And then it says an excess of NaOH which gives a solution. Again, look at your qualitative analysis. Magnesium will not dissolve, it will give a precipitate, but aluminium does dissolve. So this will be C. So remember, for your practical paper, you will get the qualitative analysis sheet, but for your theoretical papers, which is this one and the structured questions paper, you will have to learn the qualitative analysis sheet. Question 14. In which list are all three compounds soluble in water? So we go through every option, every item in each list. So option A, barium chloride, yes, it is soluble in water. Calcium carbonate, not soluble in water. Let's move on, because we don't need to look further. We know that these carbonates are insoluble in water. And magnesium hydroxide is also insoluble in water, but you should probably stop at calcium carbonate because you should know that it is insoluble. And then barium hydroxide, definitely soluble in water. Calcium hydroxide, also soluble in water. And strontium carbonate is insoluble. Again, it's a carbonate. So this cannot be the answer. Option C, barium chloride, soluble. Barium hydroxide, soluble. Magnesium sulfate, also soluble. Because remember, group 2 sulfates, their solubility decreases down the group. Magnesium is on the top, so it is still soluble. And therefore C is a viable option. Let's look at D. Barium sulfate, insoluble in water. Remember, it's a white precipitate, barium sulfate. Calcium sulfate, insoluble in water as well. Magnesium hydroxide, I think it's insoluble as well, because because magnesium oxide does not really dissolve in water properly. So we can safely assume it's quite insoluble. So C is the best option here. Question 15. Anhydrous magnesium nitrate, MgNO3 whole twice, decomposes when heated, giving a white solid and a mixture of two gases, X and Y. Y is oxygen. So what is the ratio or mass of X released over mass of Y? Right. So 2MgNO3, let's always write the equation in these types of questions. It makes many things easier. 2MgO plus 4NO2 plus O2, right? We have been told that Y is oxygen, so definitely NO2 must be X. So we need to calculate the ratios, and imagine we start with 2 moles of magnesium nitrate. So we form 4 moles of nitrogen dioxide, which is X, and 1 mole of oxygen, which is Y, because you can see these molar ratios in this balanced equation. So the mass of X over mass of Y will be the 4 times, because 4 moles of nitrogen dioxide, 4 times the mass of nitrogen dioxide, 14 plus 16 into 2, over 1 into 16 into 2, because that's 1 times the mass of oxygen, because 1 mole of oxygen gas. So 1 times the mass of oxygen gas, which is equal to 1 over 0.174 when you calculate the ratio, and that is option A. Question 16. In a series of 9 experiments, to test the reactivity of the halogens, an aqueous solution of each halogen is added to an equal volume of an aqueous solution containing halide ions as shown in the table. So they've given a halogen solution on the left and the halide solution on the top. The 9 resulting mixtures are then shaken separately with an equal volume of hexane. The 9 tubes are left to stand so that the aqueous and organic solvents separate into layers. How many test tubes contain a purple upper layer in hexane? So purple is the color of iodine, which means iodine is released into the hexane layer, and we need to see in which experiment does that happen. So let's look at each one. Experiment 1, you add chlorine to sodium chloride, no iodine involved here, so this can get cancelled. Sodium bromide, we add chlorine again, no iodine involved here, so cancel this. Experiment 3, chlorine is added to sodium iodide. Now remember, a more reactive halogen will displace a less reactive halogen from its salt solution. So this will form sodium chloride and iodine is being formed. So you will see a purple upper layer of hexane. Now let's look at experiment 4. 4 and 5, no iodine involved, cancel them. And experiment 6, bromine more reactive than iodine, so it will displace iodine, and that's why you'll see the purple color. And then experiment 7, iodine plus sodium chloride, nothing happens, but you do have iodine in the solution. Remember, you've added iodine, it will go into the hexane layer, so you will see purple in each one of them, right? Because iodine is less reactive than sodium chloride, and it will not displace chlorine gas, so the iodine will stay as it is, and therefore you will see a purple upper hexane layer in all three of 7, 8 and 9. So the total number of experiments that have a purple upper hexane layer is 1, 2, 3, 4 and 5, and therefore D is the correct answer. Question 17. Z is a compound of sodium, chlorine and oxygen. It contains 45.1% by mass of oxygen. Z is prepared by reacting sodium hydroxide with chlorine. Which row shows the conditions used for the reaction and the oxidation state of chlorine in Z? So Z is prepared by reacting sodium hydroxide with chlorine. Now remember, there are two ways there are two types of reactions. One is when you react the chlorine with hot aqueous sodium hydroxide and hot concentrated sodium hydroxide, and the other is when you react it with cold dilute sodium hydroxide. So in the case of the hot concentrated sodium hydroxide, you get NaClO3. In the case of the cold dilute sodium hydroxide, you get NaClO. So using the percentage by mass of oxygen, we need to figure out which one of these it is. So for NaClO, the total mass of the compound is 23.1 plus 35.5 plus 16, which is equal to 74.6 gram per mole. And then the percentage of oxygen is equal to 16 over 74.6 into 100, and that is 21.4%. So it cannot be NaClO, which means it has to be NaClO3, but the good practice is always to confirm. So the total mass of NaClO3 is 23.1 plus 35.5 plus 16 into 3, which is equal to 106.6 gram per mole. And the percentage of oxygen in this is 16 into 3 over 106.6, which is equal to, into 100, which is equal to 45.1%, which is what we want. So we know it's NaClO3, and therefore the answer is option D, because NaClO3 only forms under hot concentrated NaOH, and the oxidation state of chlorine in Z, NaClO3, is +5 because Na is +1, O3 is -6 because -2 for each oxygen, and overall the compound is neutral, so Cl has to be +5 because +1 +5 -6 is 0. Then question 18, which row is correct? So they've given shape and bonds present for ammonia molecules and ammonium ions. So let's look at first only the shape. So ammonia molecule, it's pyramidal, as you all know. So we have already narrowed it down to A and B without even having to read everything else. And ammonium ions is regular tetrahedral, which is also common knowledge. And then ammonia molecule, all bonds present are sigma bonds because it's all H. So this is the pyramidal structure, and all three NH sigma bonds. And ammonium ion, NH, this is the tetrahedral structure of ammonium ions, and all bonds are sigma bonds because there are no double or triple bonds. So all bonds are sigma bonds. So the correct answer is A. Question 19. The table describes two possible environmental consequences of adding too much ammonium nitrate fertilizer to the soil. Which row is correct? Increased plant growth in rivers. That is correct because remember it causes eutrophication. And B and D, we narrow the answer down to. Photochemical smog. No, it does not. Ammonium nitrate does not contribute to photochemical smog. Those are only the nitrous oxides. Question 20. Hex to ene can be made by the reaction shown. Okay, which statement about the reaction is correct? So first, let's see what type of reaction this is. It's an elimination reaction, as you can see, because you are removing iodide ions and you're protonating the oxygen over here. So you are forming a carbon-carbon double bond by eliminating this iodide. So which statement about this reaction is correct? CH3 whole thrice CO negative is behaving as a Bronsted-Lowry base. So they are talking about this compound right here, and this is correct because it is removing a proton, and remember a Bronsted-Lowry base is a proton acceptor. So this is indeed behaving as a Bronsted-Lowry base. So A is probably the correct option, but we'll read all of them. CH3 whole thrice CO negative is behaving as an oxidizing agent. Nope, because nothing is reduced. So it cannot be or oxidized for that matter. So it's not behaving as an oxidizing agent. The carbon iodide bond breaks via homolytic fission. This is not correct because there are no free radicals produced. Remember, homolytic fission is when Ci, one electron will go to carbon and one electron will go to iodine. That's homolytic fission, and this creates free radicals, which means species with one unpaired electron. So no, this is not correct. This is a hydrolysis reaction. Nope, because in hydrolysis reactions, water is consumed and sometimes also produced. So no, this is not a hydrolysis reaction. Water is not involved in any way. So A is the correct answer. So next question, question 21. Structural isomerism only should be considered when answering this question. So don't consider anything else. Molecule X contains 3 carbon-carbon double bonds. 1 mole of X is reacted with 3 moles of HBr. The carbon skeleton is unchanged. How many different products are formed? So you should work for this question on the blank page. Now let's add a page over here because I can't skip to the blank page. Now let's draw out this molecule. Right. So if you think about it, this carbon atom and this carbon atom are equivalent. This carbon atom and this carbon atom, and this one are equivalent. Likewise, this one and this one are equivalent. So one option that we have for this reaction is this. Right. So this is one option. And even if this bromine goes on this carbon instead of this carbon, it will still be on 3. Remember, both of them are 3, which means that both of them will, in either case, it will be on the same carbon atom essentially, because just looking at it from the other way around. So this is one option. The second option is it goes here. I think I've drawn some more carbon atoms here. No, that's fine. So the second option is that it goes here, and what we have for the rest is 1, 2, 3, 4, 5. Yeah. Wait, I think I made a mistake here. Just a second. Right, so it stays on the same carbon atom, but instead of having it here and here, where what we'll do is we are going to put it over there. So now this is different from 1 and 2 are different here. And a third option that you have is, again, keeping this here, but this time putting the bromine here. I think I've run out of space, so I'll just move it this side. Yeah. So putting the bromine here. So this is another option. Now remember, this is different from 2 because in 2 we have 1, 2, 3, 4, 5 carbons between this set of brominated carbons, and we have 1, 2, 3, 4, 5 from this side as well. And then in the case of 3, we have 1, 2, 3, 4, 5, 6 from this side, and we have 1, 2, 3, 4 from this side. So that's what 2 and 3 that's what makes 2 and 3 different. Then we look at 4, another option, which is that we put the bromine here and we put this here. So this is one option. Again, if this goes here, it stays the same because the number of bonds away remains the same. So essentially we get 4 of the same bromines, and that's why the answer to that question will be 4, which is B. 4 of the 4 different structural isomers. And question 22, structural isomerism and stereoisomerism should be considered when answering this question. So consider both in this case. By stereoisomerism, we mean geometrical and optical isomerism as well. A colorless liquid C5H11Cl exists as a mixture of 2 optical isomers. When heated with sodium hydroxide in ethanol, a mixture of only 2 alkenes is formed. So we have these 2 pieces of information and we'll use both of them. So it exists as a mixture of 2 optical isomers, which means that it has a chiral center, and then a mixture of only 2 alkenes is formed when it is heated with sodium hydroxide in ethanol. So sodium hydroxide in ethanol, elimination, so it should ring a bell that alkenes must be forming. So first one is CH3CH2 whole twice, CHCl. Now this does not have any chiral carbon atoms, so automatically we eliminate this because this piece of information of 2 optical isomers tells us that it has to be chiral, so A is not correct. B, CH3CH2CH2, CHCl, CH3. So this is a chiral carbon atom because it has 4 different groups attached to it, and when we heat it with sodium hydroxide and ethanol, the products that we can get are CH3, CH2, CH2, CH, CH2, one is this, plus CH3, CH2, CH, CH, CH3. Because remember, the chlorine is here, which means when elimination happens, a double bond can form between these 2 carbon atoms, or it can form between these 2 carbon atoms, right? So now this one, we'll have twice into 2 because of geometric isomerism. We won't have any geometric isomers for this one because this carbon has 2 identical groups, but this compound will have exist as a pair of cis and trans isomers. So total of 3 alkenes are formed, which means this is wrong because we need only 2 alkenes. Then CH3CH2 CCl CH3 whole twice. This one again, if you see, it's not chiral, so we eliminate it directly. And then option D is the only one left, so I think it's correct, but let's see why. CH3 whole twice CH Cl CH3. This one is a chiral center. You can see for yourself 4 different groups attached, and when elimination happens, a double bond can form between these 2 carbon atoms or these 2 carbon atoms. So the 2 products that we get are CH3 whole twice CH2. This will have no cis trans isomers, only a single isomer because this carbon has 2 identical groups, plus CH3 whole twice CH3, and this one will also not have any cis trans isomers because this carbon atom has 2 identical groups attached. So in total we are getting only 2 products, which is what we want. So option D is correct. When 2-bromo-2-methylpropane reacts with aqueous sodium hydroxide, an alcohol is formed. Which diagram describes the first step in the reaction mechanism? So if you look at the first one, electrons go towards the delta negative center, and therefore this should be the preferred direction of electrons. And remember, it's 2-bromo-2-methylpropane, so SN1 will happen and not SN2, which means we can automatically cross out option C and D because it's a tertiary carbon center, which means only SN1 will happen, not SN2. C and D are SN2 reactions, and this one would be a correct SN2 mechanism, but this compound is not suitable for SN2 because it's a tertiary center. So the correct answer should be option B because the electrons are moving towards the bromine, which is more electronegative. Question 24 now. When an organic compound Q is treated with phosphorus pentachloride, fumes of hydrogen chloride are evolved, HCl. When Q is warmed with acidified aqueous potassium dichromate, the solution turns green, which means Q is an organic compound that reacts with PCl5 and it gets oxidized in the presence of potassium dichromate. So what can Q be? Option A, CH3CH2CHO. So now this will get oxidized by potassium dichromate, but it will not react with PCl5, so this will not be the correct answer. CH3CH2COOH. Now this will react with phosphorus pentachloride to give CH3CH2COCl. This is an alkanoyl compound. So we'll get this with the reaction of PCl5, but it's an acid. It's already fully oxidized. It cannot be oxidized further. So this cannot be the answer. Then CH3CHOH-CH3. It reacts with PCl5 in a nucleophilic substitution reaction to give CH3CHCl-CH3. So this is a possible answer. And it also gets oxidized to a ketone because it's a secondary alcohol. In the presence of potassium dichromate, it will get oxidized to give CH3COCH3, and therefore this should be the correct answer. Let's look at option D as well, however. Option D is a tertiary alcohol, CH3 whole thrice COH. So even though it will react with phosphorus pentachloride to give CH3 whole thrice CCl, it will not get oxidized because remember, tertiary alcohols cannot be oxidized. So this is not the correct option. Question 25. Alcohol Y gives a yellow precipitate with alkaline aqueous iodine. Let's stop here. We know that only alcohols with the formula CH3CHOH and whatever is next will react with alkaline aqueous iodine to give a yellow precipitate. So we are already zeroed it down to this. We don't know what the question is actually asking, but it's good to point out what we know from the given information. It can be oxidized to give a mixture of products including substance Z. Okay, substance Z gives a red-brown precipitate with Felling's solution, which means substance Z is an aldehyde. So this alcohol, it can be oxidized to give an aldehyde, and it also reacts with alkaline aqueous iodine. So let's see which one it can be. CH3CHOH CH3, CH2OH. Now this one has CH3CHOH, which means it will react with alkaline aqueous iodine, and it also has CH2OH because remember, to get oxidized to an aldehyde, it has to be a primary alcohol. So this part will give the aldehyde and this part will react with the iodine. So this is a viable answer. Let's look at the others. CH3C, OH, CH3, CH2, CH2OH. So this does not have the CH3 CHOH group, so it will not react with alkaline aqueous iodine. However, it does have a primary alcohol, so it will form an aldehyde, but it does not satisfy both conditions, so this is wrong. CH3 CHOH, CH2 CHOH, CH3. So this one, this has CH3 CHOH, but it does not have any primary alcohol group, so even though it will react with iodine, it will not react with the Fehling solution when it gets oxidized, because it will form a ketone. And then CH2OH, CH2CH, OH, CH2CH3. Again, this does not have any CH3CHOH. So this cannot be the correct answer. And it also does not have a primary alcohol group, so it cannot be oxidized to an aldehyde. So all in all, A is the correct answer. Question 26. CH3CH2 COCH2CH3 reacts with hydrogen cyanide to form an organic product called a cyanohydrin. Okay, so before we jump into this into the options, let's see what we know about these types of reactions. It's a ketone. It reacts with hydrogen cyanide, and automatically we know that this is a nucleophilic addition reaction, and we know that the product is going to be CH3 CH2 OH, CN, CH2, CH3. So we know the product, we know the type of reaction, nucleophilic addition. Now let's jump into the options. Option A, the cyanohydrin product has one chiral center. It does not have any chiral centers because there is no carbon atom attached to 4 different groups. So this is wrong. B, the cyanohydrin product is formed by electrophilic addition. No, it's nucleophilic addition. C, the cyanohydrin product is formed by an intermediate which contains a COH group. No, the intermediate contains a CCN group. The OH is formed later. Remember the mechanism of the nucleophilic addition? The cyanide attacks the ketone first, forming an O negative ion, and the O negative accepts a proton to form the alcohol group. So CN is the intermediate, OH is only in the final product. The formation of the cyanohydrin product requires the use of cyanide ions as a catalyst. This is correct because remember, we use NaCN as a catalyst. So D is the correct answer. Question 27. Reduction of compound R with lithium aluminium hydride gives the compound 4-methyl pentane 2,3-diol. What could be the identity of compound R? So before we answer this question, let's draw out 4-methyl pentane 2,3-diol. So we have this. It's a 5-membered straight chain because of the pentane. Let's say this is 1, 2, 3, 4, and 5, which means that there is alcohol group at 2 and 3 OH, and at position 4 there is a methyl group. So this is 4-methyl pentane 2,3-diol, and this is a product of reduction, and reduction means that this alcohol, both of these alcohols are secondary alcohols, which means there must have been ketones at this place. So the only option, which means that the starting material should have been O. So this is the starting material. I'll move it so that you can see it more clearly. Right here. This is the starting material. It gets reduced by lithium aluminium hydride to give 4-methyl pentane 2,3-diol, and we know what the answer should be. We look at all these options, and the only option that is correct is A. Question 28. Citric acid is found in lemon juice. So they've given the formula for citric acid. Which volume of 0.4 mole per dm cube sodium hydroxide solution is required to neutralize a solution containing 0.0050 mole of citric acid? So Sodium hydroxide will only react with the carboxylic acid groups and not the alcohol group. So there are 3 carboxylic acid groups, which means essentially citric acid is 3 acids in one molecule. It's better to look at it that way, which means that 3 acid groups, 3 carboxylic acid groups, means that 1 mole of citric acid will require 3 moles of sodium hydroxide, 1 mole each, to neutralize one of the carboxylic acid groups. One for this one, one for this one for this one. So 0.0050 moles of citric acid will require 0.0050 into 3 moles of sodium hydroxide, which is 0.015 moles of sodium hydroxide. And we know that volume is equal to number of moles upon concentration, which is equal to 0.015 over 0.4, which is 0.0375 dm cube. And the options are in centimeter cube, so you just multiply this by 1000, which is 37.5 centimeter cube. And that's option C. Question 29. The structural formula of an ester is CH3 whole twice, CHOCO, CH2, CH3. Now, they've given this in a very weird form, so let's draw it out to make a visualization of the ester easier. So when they say CO2, it means this. When they say OCO, they mean this. That's the difference. So CH3 whole twice, CHOCO means this, CH2 whole twice, CH3. So the ester is boiled with aqueous hydrochloric acid. Now this should immediately strike your mind that this is a hydrolysis reaction in which we break the ester back into its alcohol and its carboxylic acid components. So the alcohol will be this part, which is CH3 whole twice, CHOH, and the carboxylic acid is this part, which is HO2C, CH2, CH2, CH3. So this is the product, and now we'll start reading the options, having all of the information in our hands. Which 2 products are formed? Oh, we just drew them out. So this one is propan 2-ol. This one is butanoic acid. And we need to find the options, which basically says this, and that's option B. So writing everything out by looking at the information given in the question will make your lives 100 times easier. The infrared spectra of 3 organic compounds are shown, spectrum 1, 2, and 3. So we will go through each spectrum one at a time before reading all the options, so that we've done all our research before delving into the interview, which is the questions. So each peak we'll label. So this at around 1300 is CO, and then the CO single bond. The sharp peak around 700 is carbon oxygen double bond, and then CH. This one here is CH, which is carbon hydrogen bonds. And then we look at spectrum 2. This has to be OH, alcohol, because remember, broad, strong peak, carbon oxygen double bond, carbon oxygen single bond. So now stop right there, and you have an OH group, you have a C double bond O group, and you have a C single bond O group. And this is most likely to be a carboxylic acid. Now, not necessarily, but it's always good to estimate what it can be, because when you jump into the question, maybe this CO and this OH are in opposite places, for example, like this. But this is very probable, and therefore it's nice to keep these things in mind, so that when these ideas come to your mind, answering the question becomes a lot more easier. And then spectrum 3, OH, this one is probably CH, and then C single bond O right here. So this one is likely to be an alcohol, because it has C single bond O and OH, and it does not have any C double bond O's. So we have all of this information in our hands. Now let's answer this question. Which could be the three compounds be? Spectrum 1. We know that spectrum 1 has C double bond O and C single bond O, and that is present not in propanoic acid. It is present in propanone. It is present in propane 2-ol, and it is also present again in propanone. So A, B, and C are likely. And spectrum 2. So we had, remember I said it is likely to be a carboxylic acid, so propanoic acid. So that means C cannot be the answer. It is between B and D, the competition. Spectrum 3, it is likely to be an alcohol, and that is propane 2-ol over here. Remember, it cannot be propanone because it does not have a C double bond O stretch, and therefore the answer is B. Question 31. Which changes can be used to measure the rates of chemical reactions? The decrease in concentration of reactant per unit time. Yes, that can be used, because obviously if the rate is basically, the rate will be negative because it's decrease in reactant, but still it's a rate of reaction. The rate of appearance of product, likewise, this will be positive. The increase in total volume of gas per unit time at constant pressure for gas involving reactions. Yes, definitely. So the answer is A. Iron reacts with steam to produce hydrogen and an oxide of iron, Fe3O4, which is in solid state. A system containing all four substances is at equilibrium. Addition of steam at constant... what changes will decrease the mass of iron present at equilibrium? Addition of steam at constant pressure? Yes, because if you add steam, the equilibrium will shift to the right, because an increase in concentration of reactants will mean that the system will make more products to decrease the reactants and return to equilibrium. Increase in overall pressure. So the same moles of gas on both sides, so the pressure will remain the same, and therefore this is not correct. Addition of an effective catalyst does not affect equilibrium, because catalyst speeds up the reaction, both forward and the reverse reactions. So this also does not affect the amount of the mass of Fe present at equilibrium. So when we add more water, the H2O, more Fe will be consumed to make more products. So that's why the mass of Fe will decrease. Ethylene glycol, HOCH2CH2OH is used as a deicer. It allows ice to melt at temperatures below 0 degrees Celsius. Okay, which statements are correct? Ethylene glycol disrupts the extensive network of hydrogen bonds in ice. Yes, because if it disrupts the hydrogen bonds, it will be easier to melt the ice, so the ice will melt even before 0 degrees Celsius. Ethylene glycol molecules form hydrogen bonds with other ethylene glycol molecules. That's correct as well, because they have these OH groups to form hydrogen bonds. Ethylene glycol molecules will dissolve in the water formed from the ice. This is correct as well, because the OH groups in ethylene glycol will form hydrogen bonds with water molecules, and hence dissolving will happen. So A is the correct answer. And sorry, for 32 I hadn't written the answer, which is D. And then for 34, which molecules contain at least one unpaired electron? So let's see. NO, let's draw the structure. So N has total 5 electrons, 1 in this bond, 1 in this bond, 1 in this bond, and then a lone pair, so 5 electrons. Then oxygen should have a total of 6 electrons, 1 here, 1 here, 1 here, 3, 4, 1 and 5, and then last one 6. This is unpaired, so yes, this has an unpaired electron. NO2, the structure of NO2 is this, NO negative positive. So overall the molecule is not charged, but within the molecule there's charge separation. So this oxygen has a total of all the oxygens have a total of 6 electrons. So 1, 2, 3, 4, 5, and 6. It's negatively charged, so it will actually, this one will actually have a total of 7 electrons, so all paired. And then because 1 from here, 1 2 3 4 5 and 6, and then this oxygen over here will have 1 2 3 and 4, and then 1 here and 1 here, so total 6 all paired. And then the nitrogen will have 1 here, 1 here, 1 here, so 3 electrons there. And nitrogen has 5 valence electrons, but this is N plus, so it will have 4 valence electrons, which means there'll only be 1, which will be unpaired. So yes, this also has an unpaired electron. Ammonia, NH3, NH3. So hydrogens have only 1 electron, so all in the bonds, so paired electrons. And then the nitrogen has 5 electrons, 1 here, 1 here, 1 here, that's 3, and then 1 and 2, that's total 5. So no unpaired electrons in ammonia, so the answer is, B, not C. Which elements form a chloride in which both covalent bonding and coordinate bonding are present? So aluminium, yes, because it forms Al2Cl6, which has covalent and coordinate bonding. Remember, this is what it looks like. This is what Al2Cl6 looks like. They are covalent bonds and coordinate bonds. Silicon only forms SiCl4, which is all covalent. Magnesium forms MgCl2, which is neither covalent nor coordinate, it's ionic. So both of them are not correct, and therefore D is the correct answer. Question 36. Which statements about calcium oxide are correct? It can be reduced by heating with magnesium. This is wrong because calcium is more reactive than magnesium. So magnesium will not displace calcium from calcium oxide. So this is wrong. It is produced when calcium nitrate is heated. Yes, because remember 2CaNO3 whole twice gives 2CaO plus 4NO2 plus O2. So it is produced, calcium oxide is produced when calcium nitrate is heated, and it reacts with cold water. Yes, calcium oxide reacts with cold water to give CaOH whole twice, calcium hydroxide. So 2 and 3 are correct, which means the correct answer is C. 37. A diketo acid is a compound with 2 ketone groups and 1 carboxylic acid group. Okay. Which statements about the reactions of limonene and terpinoline are correct? When reacted with an excess of hydrogen and a nickel catalyst, limonene and terpinoline produce the same compound. So when we react limonene with hydrogen, we get, because all the double bonds will become single bonds, then it will become a saturated hydrocarbon. So essentially, yes, they do form the same compound. An excess of hot concentrated acidified KMnO4 with an excess of hot acidified KMnO4 reacts with limonene and with terpinoline to form different diketo acids. Let's see what happens. So if we just look at limonene for the time being, then this group reacts with, this double bond reacts with the concentrated acidified KMnO4. This will form a ketone because it is attached to one R group over here and one R group over here. And this will form a carboxylic acid. So one ketone, so let's say K, and one carboxylic acid, let's say C. And then here we'll get another ketone because R and R. So 2K, this is the second ketone. So 2 ketones and 1 carboxylic acid. And then this one will be CO2, which will just go off somewhere. So essentially, in total, we have 2 ketones and 1 carboxylic acid. And the first statement of the question said, a diketo compound is a compound with 2 ketone groups and 1 carboxylic acid group. So yes, this is a diketo acid. And then terpinoline, ketone, and this will give carboxylic acid. This will give ketone. So K, C, K. This will give ketone as well. So, but this will be a different ketone. So we have a ketone here. We have a carboxylic acid here. And we have a ketone here. And then in limonene, we have a ketone here. We have a carboxylic acid here. So Till now, it is the same as terpinoline. Both limonene and terpinoline are same till here. But if we look at limonene, there is no ketone forming here. It's only forming here. But in terpinoline, the ketone is forming here. And therefore, they form different diketo acids. And therefore, option 2 is correct. The reactions of limonene and terpinoline with an excess of Br2 produce positional isomers with the same number of chiral carbon atoms. Okay, so let's look at what happens when we react limonene with Br2. We get Br, 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 Br. This is what we get when we react limonene. So we have bromine here, we have bromine here, we have bromine here, and we have bromine here. Right. And then the chiral centers, let's mark them with a different color. 1, 2, 3, and 4. 4 chiral centers here. Now, when we react terpinoline with bromine, we get bromine, bromine. I think this, I just drew a straight line which is slightly confusing, so I removed it. Bromine and bromine. This is what we get. Positional isomers, yes, because they have bromines in different positions. But let's see the number of chiral carbon atoms here. This one, this one, this one, and this one. No, not this one, sorry. This is, there are only 3 chiral carbon centers here, which are marked in blue. So the option says they have the same number of chiral carbon atoms, but as we can see, they have different numbers of chiral carbon atoms because limonene, the limonene product has 4, whereas the terpinoline product has 3. So the option 3 is wrong, and therefore B is the correct answer. The third last question, one molecule of dodecane, C12H26, is cracked producing 3 product molecules X, Y, and Z. X is a straight chain alkane, Y and Z are straight chain alkenes with different MR values. Which statements about X, Y, and Z are correct? Okay, so we know X is straight chain, Y and Z are X is straight chain alkane, which means saturated, Y and Z are straight chain alkenes, and they have different MR values. So these are unsaturated. And which statement is correct? So we'll go through each and every option. If Y and Z are butanene, which is C4H8, and ethene respectively, which is C2H4, X will be hexane, which means it should be C6H14. Let's add all of these up. C4 plus C2 is C6, C6 plus C6 is C12, so the carbons is matching because we need 12 carbon atoms total. H8 plus H4 is H12, H12 plus H14 is H26, and we have 26 hydrogen, so this is correct. If X is butane, which is C4H10, then Y and Z should both show, could both show cis trans isomerism. Could both show, not should both show. That's what it is. So C12H26 gives C4H10 according to them plus 2 other products. So this means we are left with 8 carbon atoms and 16 hydrogen atoms. So we can have some combinations here. For example, C2H4 and C6H12, and or we can have C3H6 and C5H10, or we can have 2 times C4H8. Now this is not possible, the last one, 2 times C4H8, because it says that Y and Z are different, have different MR values, so both can't have C4H8 as a formula. And then these 2 options, both of them don't show cis trans isomerism, because C2H4 is this, so they can't show cis trans isomerism because both carbons have identical groups attached, and C3H6 is CH3, CH, CH2. This carbon has 2 identical groups attached, so cannot show cis trans isomerism. So this option is wrong. Option 3, X could be octane. So if X is octane, then C12H26 minus C8H8 18 gives C4H8 and yeah, so if we are getting two products, that means both are C2H4, because that's the only possible way to get them adding up to C4H8 and for them to be an alkene. And we cannot have two of the same products, because so first of all, we can't have CH4 plus C3H6. This doesn't work at all. We can't have this, and CH4 is not an alkene, and the hydrogens don't add up. So the only option is 2 times C2H4, and this is not possible because Y and Z have to be different. So this is wrong. Correct answer is D, because 1 is the only correct option. Penultimate question: which statements about chlorofluoroalkanes are correct? Both the carbon chlorine and carbon fluorine bonds are readily dissociated by ultraviolet light. Okay, this is wrong, because only carbon chlorine, the Cl bond is readily dissociated by ultraviolet light. Cf is very strong and it cannot be dissociated with by ultraviolet light. So this is wrong. They have caused ozone depletion. Yes, that's why CFCs, we don't use them anymore. And if you know someone who uses them, please report them. And then they are relatively chemically inert. Yes, they are not very reactive. That's why they are used in aerosols, because they are inert. But they were used in aerosols, not anymore. They are very bad for the environment. So the correct answer is C. Last question, question 40. Which reactions of propane 1-ol have water as one of the products? Passing propane 1-ol vapor over hot Al2O3. This is a dehydration reaction in which an alkene forms. Which reactions of propane 1-ol with water have? Which reactions of propane have water? Yes. So dehydration releases water to form an alkene, and therefore this is correct because water is one of the products. Mixing propane 1-ol with warm ethanoic acid and a few drops of concentrated sulfuric acid. This is an esterification reaction, and remember, esterification reactions also release water, so this is correct too. Warming propane 1-ol with HBr. This is a nucleophilic substitution reaction, and it also forms H2O because you get 1 bromopropane and H2O as the product. So this is also correct. Option A is the answer. So this was the October-November 2021 paper 11, and this is how you solve these types of questions. If you have any problems, leave them in the comment section below. I hope this helps. Thank you so much.